Hello there. My name is Tony Silk. I am a math teacher at the Harker School in San Jose, California. I am also an AP Precalculus consultant. I teach both AP Precalculus and Calculus. I was asked to do a AP tips and tricks video, and so here we go. Most of this is going to be more related to calculus than precalculus because as of right now, and that's August of 23, the pre-calculus exam doesn't exist yet. We haven't seen one, so I can't tell you exactly how that's going to play out or how it's going to be graded. But I suspect much of what is true in calculus will also be true in pre-calculus, so I'm going to talk to that line. All right, so first I want to talk about some basic timing strategies. For both the pre-calculus and the calculus exam, the order is the same. It is multiple choice, no calculator, then multiple choice calculator, then free response calculator, free response, no calculator. The number of questions is different. There's only 4 free response questions in the pre-calculus exams, 6 in the calculus exams, and the multiple choice is obviously comparatively different as well. The big thing about timing when it comes to this test, both in the multiple choice and the free response, is you should have a sense of how long each question should take you. A no calculator multiple choice question should take you about 2 to 2.5 minutes, and a calculator multiple choice test question should take between 3 and 3.5 minutes. The free response questions are 15 minutes for all of them. Now, there's some variation there, and it could be a little bit more, a little bit less, but that's a pretty good average. What that means is that you shouldn't be spending more time than you really have on any one problem, specifically because all the points are the same across the board. So every multiple choice question is worth the same amount. Every point in the free response section is worth the same amount. So if you spend 10 minutes getting 1 point on a free response question, it's not like you've got a better point than if you had spent those 10 minutes getting 8 points and missing that last 1 point because it took you 10 more minutes to do it. Hope that makes sense. So for multiple choice, as the students are practicing multiple choice, they should keep in mind how long it's taking them. And one good way to do this is actually just do a bunch of multiple choice questions. So if you take a bunch of old multiple choice questions, let's say 5 multiple choice questions, it should take about 15 minutes to do those. 10 should take about 30 minutes to do. So if you give a student 10 multiple choice questions and it takes them 40 minutes to do that, then you have to figure out why that is. And there's really 2 possibilities. The first is they're just not as efficient across the board. So every problem just takes them a little bit longer than the mean. And so therefore they're just not getting done. The second possibility, and the more common possibility, is that there are 1 or 2 questions that are bogging the students down. So they'll get through questions 1 through 4, they'll get to question 5, and they'll take 6 or 7 minutes to get through question 5. And they may not even get it right, but they'll sit there and they'll work on it for a long time. Well, if they do that, by the time it gets to minute 30, let's say out of 10 questions, they haven't gotten to questions 8 or 9 because they spent so much time on question 5. If that is the case, and if that's what's happening to students, then they need to practice getting a sense of how's this question going? Or more specifically, if they get to a question and they don't pretty much immediately know how to solve it, not what the answer is, but how to solve the problem. And that means, take 10 or 15 seconds, start thinking about it and go, yep, I know how to do this. If they're sitting there and after 10 or 15 seconds and they're sitting going, I still don't know what I'm doing, then it's time to move on. Skip the question, come back to it. That's true for multiple choice and free response. The trick with the free response, of course, is Part B may rely on Part A. That's especially true for calculus, less so for pre-calculus. So you don't want to necessarily just give up. But on the other hand, the questions are generally written so that if you can't get Part A, say, you still should be able to do Part B or Part C. It shouldn't take you out of the entire question. So if you're sitting there and you're like, I can't do this, or I don't know how to do this, skip it, move on, do the rest, and then come back if you have the time. So that may mean you get through all the other multiple choice questions and there's still 2 questions that are going to take you 15 minutes to do them. If you don't get to them, okay, you only missed 2. But if you did do those, you wouldn't have gotten to 5 questions somewhere else along the way. So I hope that makes sense. But it's an important thing for students to practice because the calculus exams and the pre-calculus exam, I suspect, are generally not ones that students finish early. So there are AP exams where I've seen kids after, an hour for an hour and a half section, they're done. That doesn't happen for the calculus exam very often, or the pre-calculus exam, I suspect. So the kids should be practicing their timing, getting ready to get into the AP exams. All right, some calculator tips and tricks. Let me bring up my TI emulator. So this is TI Smart View for the 84 CE calculator. My school has purchased this software. I assume it's available to purchase. I don't know if you can download it for free other than for a trial version or how to get this. It's really nice because you can project it. And if you've got a smart board or any kind of enhanced whiteboard, you can actually tap on the calculator and do it exactly. So there's a couple of things here that I really want everyone to be sure that they understand how to do. And here they are. The first thing is you've got to know your modes. So the mode button here is very specifically radians. Both for pre-calculus and calculus, everything is in radians. So the first thing a student should do is check to make sure they're in radian mode, and they should never change that. Now, you can see down here, we've got also function, parametric, polar, sequential. For the BC exam, the function, parametric, polar will be important. For the pre-calculus exam, polar will be important, parametric, not so much, sequential, not at all. And students should be understanding how to use those. But truthfully, even in pre-calculus, I think you can get away without doing the polar, although you want to be able to do the polar graphs on there, so you should know where that is. If you go to polar mode, and here I hit enter, when I go to y equals, which is my graphing, you'll see now it's r equals as opposed to y1 equals. Okay, the other things that you really absolutely have to know, there's obviously a lot you need to know for your calculator, but these are the things that some students don't know, and you really want to make sure that they do know. One is how to store a value. So I've created 2 functions here. I want to graph those. And what I want to do is find the intersections of those. And I'll just find the right intersection right here. And then we're going to store those 2 values. We're going to store the x and the y value. So to find the intersection, second, calculate intersection, 5. And first curve, second curve, I just click enter. There's no reason to move the cursor at all. Guess. Now in this case, there's 2, so I'm going to move the cursor a little bit over to the right so that it guesses this one. And there it is, it's found the intersection. Now what I want to do is store those values. I want to store the x value, which is 1.26, and the y value, 0.589. So to do that, first get out of the screen, because otherwise you're going to start trying to play with the graphing, which you don't want to do. So second quit, or second mode, you see that it's quit there, gets out of here. To store, that's the store button here. We've got this cleared out. Answer and x are the same thing. So we can store the answer or we can store the x value. It is the same here. So one thing that's nice is if you do nothing and you just click the store button, which is down here, store. Answer's over here. There's answer, so second negative sign. But if I just click store, it's going to do answer dash, and answer is x. And I'm going to store that in A, alpha A. So there's my x value, and it's stored in A. So if I just click A, alpha A, and hit enter, there it is. Now, if I want the y value as well, y is not stored anywhere except in y. So if I do alpha y is down here, store, and I'm going to store that in B. So there's 0.589, that's stored in B now. So now I can do anything that I want between A and B. So I can look if it's increasing or decreasing, or if it's calculus, I can do the area between 2 curves, whatever I want. I have stored those, and that's really important. especially because, as you can see here, the y value is good to, I don't know how many decimal places. The calculator is storing it to 32 decimal places or something. We don't want to round until our final answer. And so what students might do is they would look at this and go, oh, it's 0.589, and then use that for some second calculation to get to their final answer. But now they've rounded in the intermediate, which you never want to do. So that's why we want to store stuff so that we have the full value until the very end. And at the very end, then you can round, and we always round or truncate to 3 decimal places. You can do either. So rounding, in this case, well, let's look at the previous one. A, 1.260, 1.261, or 1.26 will all be acceptable answers. You don't need a trailing 0. And we can truncate after the 3rd decimal place. So if we truncate that one, it's 1.260, that 0 disappears. Or we can round, 1.261. Both of those are acceptable in calculus, and we expect they will be acceptable on pre-calculus. All right, so that's how you store, and you see in the second calculate, also min and max is there as well, and finding zeros as well. You should be able to do all those. Just as a reminder for the calculus exams, the minimum and maximum are verboten. That is, you're not allowed to use those to find a min or a max. You've got to use a first derivative test or a second derivative test to find mins or max. I mean, a student can always, they have a calculator, you can use that, but that will never be a justification on a calculus exam. For pre-calculus, you've got those buttons. If you want to find a minimum, you can use those buttons to find those. The other thing that I want to show you how to do is doing basically a store again, but not with a constant, but with a function. So we've got y here. y1 is x squared minus 1. That is, I can use y1 wherever I want. So for example, if I wanted to find y1 of 5, so again, second quit gets me out of the screen, I can do that from my screen here. And the way to do that is I need y1, and to get there, it's alpha, and then F4, trace. And you can see here, it pops up all my y variables. And this is F4. F3 will give me my matrices, F2 will give me functions, and F1 will give me fractions. So changing from decimal to fraction or back. So, but I want y1, so I hit enter, y1, and then use the parentheses of whatever I said, 5 is 24. And in fact, I can do a composite function. I can say alpha of y1 of alpha 2 y2, that's 2 of 3. And there you have the composite function. Now, the TI-84 is not a CAS, not a computer algebra system. So you can't ask it for a y1 of y2 of x. It won't do that. The TI Inspires with CAS mode will. And then also the HP primes and the TI-89s with CAS will do that. But here, we're just doing numerical stuff. So you can see that you can use y1 wherever you want. And in fact, in y equals, I can do that as well. So here's y1. I can graph the absolute value of y1, for example. And so we'll come down here to y3, and I could say absolute value. So that's math abs of y1. Well, where's y1? Alpha, F4, y1. And now when I graph it, actually I'm going to turn off y2 here. So now I'm graphing y1 and y3. There's y1, and there's y3 on top of it, which you can see is in black, which is the absolute value. And in fact, you can do some other wacky things. So you could do y1 of negative x. That's not going to be very interesting. I'm going to change y1 here to cubed and turn off y3. And there's y1 of negative x, which is, as you know, the mirrored around the y-axis. This is the weird case, where it's not a CAS, it's not giving you y1 of negative x. It's not going to give you that function, but it is actually going to be able to graph that because it's graphing it numerically. And so you can do all sorts of weird transformations using the original function. And that's a really nice thing to be able to do. So going to here, storing the function, and then being able to do your manipulations, your stretches, your shrinks, your vertical stretches, etc., in the y function. Okay, a couple other really quick things since I'm here. If you go over to the little line and you hit enter, you can change this. So I can make this a dashed line or an upper or lower, etc. So you want to be able to play around with that. So here I will graph it, and you can see one's dashed now, dotted. Very nice thing to do. And the last thing is, in precalculus, less in calculus, we're going to do some statistics and some residuals. And when we do that, we're going to use the plot functions. If you have the plot functions turned on, so you see this plot 1 here, which means it's plotting it. Sometimes, depending on what's being plotted, that will prevent the calculator from doing any kind of graphing. So sometimes a kid will say, hey, I can't graph anything. And you come and you look at their calculator and you'll see this, and they're trying to graph this, and plot 1 or plot 2 or plot 3 is highlighted. Sometimes what's in there will prevent it from being graphed. Just come up, go over that highlight, and turn that off. And then usually they will clear that up. And that's coming from stat plot, so second stat plot here. That's where the plots are. Again, that's if you're in precalculus or teaching stats, you need to know all that stuff. I won't get into here, but just a good calculator tip. All right, back to our regularly scheduled program. I've already talked about the multiple choice a little bit before. Again, we have to be really careful about the timing. Make sure you pay attention to that. And also, the fact is that there are no calculator and calculator multiple choice questions. So you want to be practicing both of those, and that's for precalculus and for calculus. You really want to be practicing both. The other thing is, now that we're down to 4 possible answers, truthfully, guessing is not such a bad thing, especially if you can eliminate one of the possible choices. So if you've got 4 answers there, and you look at it and you say, well, it's definitely not A. Beyond that, I don't know. Guess and move on. That's not a bad thing to have a 33% chance of getting it right. Even if you can eliminate 2, that's even better. So some students, when it comes to timing, will keep pressing it, wasting their time. Whereas if you can just say, all right, I only have a few minutes to do this problem, instead of trying to figure out what I can do, let me figure out if I can eliminate anything. And sometimes you can do that. It's not a bad strategy for multiple choice, and use any strategy that you can. Sometimes as well, you can look at the answers, and from the answer, you can work back to the problem. And you'll see what that is depending on the different calculator problems, depending on different multiple choice questions. In calculus, for example, if it says which one of these is the correct integral, well, you could take the derivative of all of them and see which one comes back to it. It's a little longer way of doing it, but that can work. Free response questions, not a whole lot to say here other than practice, practice, practice. For calculus, absolutely, just practice as much as you can. And pre-calculus, since these are task models, you really want to be practicing those a lot. Question number 3 in the pre-calculus world, you're going to want to do 1,000 of those if you can, because they're all going to kind of look the same, so the students walk in knowing exactly what it's going to look like. 15 minutes, they should be practicing 15 minutes. It doesn't mean you have to stop a student after 15 minutes. It does mean, though, that you should tell the students, hey, it's been 7.5 minutes, it's been 10 minutes, something like that. And then at 15 minutes, it's been 15 minutes. How far are you? It doesn't mean that you should stop after 15, because some questions can be done in, say, 12 minutes, which means another question could take 18. But getting a sense of that is a really good thing. Some general procedure stuff for the free response questions. First of all, as I mentioned, read all the instructions. 3 decimal places for the multiple choice, rounded or truncated. Don't round in between. Also, part A always goes in part A. Part B goes in part B. So if your answer to part A is in part B, it's not going to get read unless somewhere in the box of part A or in the writing of part A, you write C part B. The other way, if you do part B in part A, sometimes that'll work, but the first way is bad. So being very clear about in part A, you're doing part A, in part B, you're doing part B, and if you're not, making sure that the reader knows where they should find that work. On the other hand, don't box your answers, because anything that's boxed is going to be read as the final answer. And sometimes we can ignore some stuff if it looks like it's just students scribbling. So here's an example of that. I'll write this down right now. If a student is doing this, and it looks like this, and there's work up here, work above. What it looks to me is the kid did the work, 3 plus 5 got 8. I'm going to be okay with that. If this is boxed, then even though it looks like the kid did the work, they got to 8, and they boxed 15, 15 is their answer. So, no. On the other hand, if they've done the work twice, so it looks like this, so you're actually seeing both sides here, then we're going to grade both. We'll grade the 8 and the 15 and score both. So this one, the 8 would be correct, the 15 would be incorrect, and then average the scores and round down. So if this is worth 1 point, and this is worth 0 points, you get a half point rounded down to 0. So that's referred to as a parallel solution. Don't do that. Don't do the question twice. And so if a student says, well, if I'm not sure the answer, I'll write 2 different answers and have the teacher, the reader, choose the better one. No, the readers won't do that. What to write, what not to write. Some students will, when they don't know exactly how to do a problem, write down what they, will write down the sort of the procedures to do the problem. They'll say things like, well, if I knew how to do this problem, I would first do this, then I would do that, whatever that might be. So for example, if the problem says in calculus, find the minimum, the student would write, the first thing I'm going to do is going to find the critical values. Then the next thing I'm going to do is look to see if the derivative changes signs around that critical value. That will tell me if it's a min or a max. That's lovely and correct and will get you no points. Don't tell me what you're going to do, just do it. Now, there's a slight caveat to that. In a certain level, I do want you to sort of say, here's what I'm leading up to. So, for example, using the derivative, I want you to say f prime equals 0, and then the next line, show me that, okay, here's the derivative, and I'm going to set it equals 0. So you're sort of mathematically saying, this is what I'm trying to do, and then doing it. But just verbally explaining to me what you would do if you could do the problem is never helpful. So make sure that you're not doing that. The other thing, and these are more nots than there are to do, is never use it or any other vague pronouns. So things like the function is increasing. What function? And especially if you've got multiple functions going on. So in calculus, f and f prime are both functions. And so if you're saying if you're saying the function is increasing, which function? F prime. Even in precalculus, if you've got f and g and f of g, and then you say the function is increasing, we've got 3 functions. We've got f, g, and its composite. So you want to be very clear. F is increasing. G is concave down on the interval, etc. Those vague words, it is the biggest one. We'll always lose points because we never know exactly what you're talking about. Okay, showing your answers. Again, like I mentioned before, you want to be very clear about that. Don't box your answers, but make sure you're writing your answers. Equal signs are good. Beware of linkage errors. So a linkage error looks like this. 3 plus 5 equals 8 plus 2 equals 10. That's a linkage error. So that is A does not equal B does not equal C, or A equals B and B equals C, but A does not equal C. Or in other words, it fails a transitive property. Anything like that is a linkage error. We want to be very careful about that. But otherwise, we do want to make sure that we are showing all our answers very clearly, showing the work along the way. If you just write an answer, it's referred to as a bald answer, so you don't show any work. That almost never gets you points, except perhaps in the calculator portion where you can do the work on your calculator. So making sure that you are showing your work. A difference quotient is the most common one. So if you're saying f of 3 is 8 and f of 5 is 15, what's the average slope? Don't just write down 7/2. What we want to see is 15 minus 8 over 5 minus 3 equals 7/2. Now, in the calculus world, you don't have to simplify. So 15 minus 8 over 5 minus 3 is acceptable. In pre-calculus, it is not. So in pre-calculus, we don't use the word simplify, but reduced is the better way of saying it as best as you can. 7/2, 3.5, both of those are fine. Unless it specifically says, give me a decimal answer, then you better give a decimal answer. But anything that can be reduced, so natural log of 1, natural log of e, square root of 4, any of those things that could be easily reduced need to be reduced in pre-calculus. Calculus, that's not the case, but in pre-calculus, it is the case. Fortunately, pre-calculus comes before calculus, so the students will get used to that, and then when they get to calculus, we can say, yes, we know you've practiced it, but now you can sort of forget that. But up until then, better for them to reduce all their answers as best as possible. All right, some other common mistakes that students make on the free response questions. The biggest one that I want to mention, and I've been talking for a long time, so I'm going to wrap this up pretty quickly. The biggest one is actually parentheses issues, because missing parentheses can really throw things off. And so this is clarity of writing. So if you say f of g of x plus 3, I don't know if you mean f of g of x plus 3 or f of g of x plus 3. And in pre-calculus, I'm not sure how they're going to grade that. In calculus, this tends to come up most with integrals. So that integral will be read as the integral of x plus 3. And if the student meant this, well, then they've gotten it wrong. Because without the dx, which is like a closing parentheses, we don't know how to actually read this problem. And if a student did this, would it be? I don't know. But that sort of being clear with your parentheses and your equal signs, where they are, is probably the most important thing, the most common mistakes that we see in calculus. And I would suspect we're going to see the same in pre-calculus. The second one, and it's just a huge wide gap, is just simplification or reduction mistakes. The number of times that I have seen stuff like this is incredible. And maybe not 4 plus 3, but I have seen 9 times 7 equal to 72 more than 10 times over my years of grading calculus. It's not correct. And again, in the calculus world, 9 times 7 would be acceptable answer. In pre-calculus, actually, 9 times 7 is not enough. They have to show me that it's 63. I don't know if there would ever be a problem that would come like that. But those kind of simple mistakes, parentheses, simple addition, etc., are where students most commonly mess up. And so those are the things that you want to be very aware of and let the students practice and check themselves on. And in fact, I would have some student responses, or make up your own student responses, that have those kinds of mistakes in them, and let the students see them for themselves so they can start recognizing that in other work, and then hopefully they'll recognize it in their own work. And the last thing is about scoring. Remember, multiple choice, they're all worth the same. So it's either right or it's wrong. Free response, it's only whole points. So 6 points total for pre-calculus, 9 points total for the calculus exam. Students will not know what their scores are. Specifically, you don't get a specific score back. A average score is usually in the middle for calculus. I suspect it's going to be the same for pre-calculus. So out of 6 points, expect the average to be about 3.5 to 4. The other thing that we worry about for scoring, and there's not a whole lot that you can do about, is, hey, if I write this, then do I get the point or then do I not get the point? I would not spend a lot of time, whether you're teaching pre-calculus or calculus, going over that minutia. For pre-calculus especially since we don't know what the scoring is going to be like yet. But when you see the scoring guidelines that come out with the practice problems on AP Classroom or other places, those are really guidelines. And how things are scored will vary year to year, and it'll depend on what the question is and what the expectation is from the students and how the students do. So don't sit around and try and nitpick, is this a point, is this not a point? In your classroom, again, this is my tip at least, in your classroom, grade things the way you grade them. And if a student says, well, will I get a point on that on the AP exam? Really, that is kind of meaningless. In my classroom, at least, if it's wrong, then I'm going to take points off. And whether or not they take a point off on the AP exam or not is immaterial. And the calculus example would be if a student wrote this, I'll do something simple. 0 to 3 of x squared equals x cubed over 3 from 0 to 3 is 9, which, sure, let's assume that that's correct. I'm going to take off a point because the kid forgot the dx. Will the AP exam do that? Probably not. Does that mean I shouldn't take off the point? No, of course I'm going to take off the point. The kid should know that. And if the kid says, well, can I forget the dx on the AP exam? Let's not worry about that. I'm telling you it's wrong because it is wrong. It needs the dx, and that's what we're going to practice. So I wouldn't worry so much about AP scoring, especially until we see it. Once we've seen it, then it's good to see how things are scored, not to say what you will get a point for, what you won't get a point for, but more for look at the kinds of mistakes the students are making. Are we making those same kinds of mistakes, and how can we avoid them? All right, that in a long amount of time, in 30 plus minutes, is my tips and tricks for the AP exams. I hope you found some of this useful. If you did, great. If there's other things that you want to ask about or talk about, feel free to share this video with anyone you like. The videos are unlisted, but you can share the link. If you have questions to me, do not hesitate to email me. My email is my name, anthony.silk@harker.org, and I'm going to write that on the next screen. There's my email address. I would also encourage anybody who's teaching AP Precalculus or Calculus or any of the APs to get onto Facebook and join some of these communities, the AP Precalculus teachers, the AP Calculus teachers groups. If you're a reader, join the readers communities. If you're a consultant, join the consultant communities. Lots of really great information is being spread through those Facebook pages. Will we switch over to Instagram? Probably at some point. But right now the teachers are all old, so we're still using Facebook. But great way to find resources out there. I have other resources as well. If you're looking for some, I can provide some. But Facebook is a great place to start. Again, I hope you enjoyed this, and I hope you found it useful. Best of luck to you in your classroom and to your students on the AP exam.